Hi, welcome to the Moon Tech City YouTube channel. Today, we are going to look inside one of the most common, yet potentially dangerous household appliances, the microwave oven. Before we talk about components or diagnostics, we must establish the absolute golden rule of microwave repair: safety first. Microwaves are not like standard electronics. They utilize a massive high-voltage capacitor that can retain a lethal electrical charge long after the appliance has been unplugged. Never skip safety protocols. Always unplug the unit and always manually discharge the capacitor using an insulated screwdriver before touching anything inside.
At first, I am going to explain microwave ovens in a simple way for new users. I will talk about how microwave ovens work, how to use them properly, and the most important safety precautions to follow. Then, we're going to look inside several microwave ovens to show you the core components that make up the high-voltage circuit responsible for creating heat. We will also try to explain the basic troubleshooting with the step-by-step guidelines for replacing faulty components and help you to repair your dead microwave oven. A microwave oven is a kitchen appliance used to heat, cook, and reheat food quickly. It saves time and is very convenient for daily use. Unlike a traditional oven, which heats food from the outside using hot air, a microwave oven uses electromagnetic waves called microwaves to heat food.
So, how does a microwave oven work? Inside the oven, a part called the magnetron produces microwaves. These waves pass into the food and make the water molecules in the food move very fast. This movement creates heat, and that heat cooks or warms the food. That is why foods with more moisture usually heat faster in a microwave. We take the microwave oven completely for granted today. But its invention wasn't the result of a deliberate, calculated effort to revolutionize cooking. It was born from a complete, beautiful, and slightly messy accident. In 1945, Percy Spencer was working as an engineer for the Raytheon Corporation. Percy was working with a device called a magnetron, a vacuum tube that generates microwave radio signals. One fateful day, Percy was standing in the lab, running a test on an active magnetron. He was fully focused on the complicated machinery in front of him. But then, he noticed something strange. He realized that the invisible waves from the magnetron he was standing next to had cooked the chocolate right inside his pocket. It had completely melted right through the wrapper. From that sticky, melted chocolate bar in an engineer's pocket, the concept of the microwave oven was born. Now, I will explain some important safety precautions. First, never put metal objects like spoons, aluminum foil, or steel containers inside the microwave because they can cause sparks and damage the oven. Second, always use microwave-safe dishes. Some plastics can melt, and some containers may crack under heat. Third, do not heat sealed containers or unopened bottles because pressure can build up and cause them to burst. Fourth, be careful when heating liquids like water, milk, or soup. They can become extremely hot and may spill suddenly when moved or stirred. Fifth, never operate the microwave when it is empty because this can damage the appliance. Sixth, keep the microwave clean. Food spills inside can burn and create bad smells or smoke. Finally, children should use a microwave only with adult guidance until they understand how to use it safely. To fix a machine, we first have to understand how it works. Let's break down the core components that make up the high-voltage circuit responsible for creating heat. The magnetron. This is the heart of the microwave. It converts high-voltage electrical energy into microwave radiation, vacuum tubes that generate standard 2.45 GHz frequencies to vibrate water molecules in food. The high-voltage transformer. This is a step-up transformer. It takes standard 120 or 240 V wall power and boosts it up to roughly 2,000 volts to feed the magnetron. The high-voltage capacitor.
Working alongside a diode, this doubles the transformer's output to nearly 4,000 volts. It also acts as an energy reservoir. The high-voltage diode. This passes current in only one direction, converting AC power to DC to feed the capacitor and magnetron. The door interlock switches. These are critical safety microswitches. They ensure the microwave only runs when the door is tightly sealed, preventing radiation leakage.
When a microwave comes in broken, how do we diagnose it? We use a logical process of elimination based on symptoms, followed by testing with a digital multimeter. Here is the troubleshooting matrix. 1. Symptom: totally dead. No display, no lights. Check the main ceramic fuse or the thermal cutouts, thermostats. If a thermal switch has tripped due to overheating, it cuts all power. 2. Symptom: runs, counts down, but does not heat. This points directly to the high-voltage circuit. You'll need to test the magnetron, diode, and capacitor. 3. Symptom: sparks inside the cooking chamber. Check the waveguide cover, the small mica sheet on the inside wall. If it gets coated in grease, it will arc and burn. 4. Symptom: shuts off after a few seconds. Check the door switches. If one of the 3 or 4 microswitches is misaligned or failing, the control board senses a breach and kills power. Once you suspect a component, you must test it using a multimeter. Ensure the microwave is unplugged and the capacitor is safely discharged before doing this. Testing a fuse or thermal cutout. Set your multimeter to continuity. Touch the leads to both terminals. A beep means it's good. No beep means it's blown and must be replaced. Testing the switches. Test micro switches for continuity while manually pressing the small button. It should click and toggle continuity on and off. Testing the magnetron. Measure resistance across the 2 filament terminals. It should read very low, under 1 ohm. Then test from each terminal to the metal chassis. It should read open circuit, OL. If there is continuity to the ground, the magnetron is shorted. Testing the diode. Standard multimeters cannot easily test high-voltage diodes because they require more than a 9-volt battery to open the junction. However, you can test if it's shorted. If it shows continuity in both directions, it is dead.
Fortunately, we rarely repair individual internal components. Instead, we replace them. It is safer, faster, and ensures reliability. Here's the protocol for replacement. Replacing fuses and switches. These are generally plug and play. Take a photo of the wiring layout before disconnecting, unsnap the old part, install the new one, and reconnect the wires tightly. Replacing the magnetron. Unscrew the mounting brackets, carefully pull it out without damaging the antenna tip, and swap it. Ensure the mesh RF gasket is perfectly in place on the new magnetron to prevent radiation leaks. Replacing the waveguide cover. If it's sparking, pry the old mica sheet out. Clean the metal cavity behind it thoroughly to remove all carbon scoring control, and snap a new, cheaply replaced mica sheet into place. To wrap things up, microwave repair is highly systematic. By understanding the relationship between the transformer, capacitor, and magnetron, you can track down almost any heating failure. Remember, look at the symptoms first, use your multimeter to confirm the failure, and never, ever compromise on discharging that capacitor before you begin your work.
And that wraps it up for today's video. Thank you so much for watching and spending some of your time with me today. If you enjoyed this video and want to see more content just like this, please hit that subscribe button and turn on the notification bell so you never miss an update. Please share it with your friends or anyone who'd find it helpful. Sharing really helps the channel grow and lets me keep making videos for you. I'd love to hear your thoughts, so drop a comment down below. Until next time, take care.